Well, good day to you, my dear friends. It's time to solve some LeetCode problems. Yay! And today we are going to start with a problem that we solved a few days ago. And what was it? This one. It's an average problem that I was able to solve, but there was so many milliseconds, like 2000 I guess, so we barely made it. But still, we solved it, and now we have the right, to look at all the other solutions. Unfortunately, there are not that many. Just two. And we're gonna start with the solution from this guy, because this one is, well, it's a modified version of that one. First of all, what is a problem? We have an array of boxes, and each of the boxes contains balls. One ball, this box contains one ball, and the last box contains 3 balls. The question is, how many moves do we need to move all the balls to each box, let's say. No, these are the boxes. And this is the answer. But you get I'm too tired today. Let me draw. Universal language. Oh, I have something here already. So, this is what we have, right? How many moves we need to move everything to the first box? Well, we just need to move this ball. So we're gonna have 2 balls here, like this. We need just 1 move. How many moves we need to move all the balls here? Well, just 1 move. How many moves we need to move all the balls here? Well, we need to move this one, it's a 1 move, and this one we have to move here and then here, so it's a +2, 3 moves. So this is our final answer. And I solved it in a crazy manner. Well, you can watch this video from a few days ago. I do not want even to repeat this. But what is the idea behind this solution? Oh. So, how do we count? How many moves we need to move everything to, say, this box? We need to count all the moves to the left, right? It's a 1 move. And all the moves to the right, and 0. And to combine them. And the idea here is that we have, well, let's get the length. And now we want to create this array that he called left. It's the same size as the number of boxes. So for this one, we create array left with 3 zeros. Let's start from here. Oh, and of course we create an array answers. Oh god. The same length, the same zeros, and we have an array right, and it's the same, 3 zeros in this case. Now into this array we're gonna add the number of moves that we need to move everything to the right, to the left of our box here, well, to this box. But we do not have anything to the left, there is nothing here. So we add 0 to the first position. And we want to have a variable that we call count, where we count the number of encountered ones in the left part, because here we have a 1, we encountered it, so let's count it. We have one once. Now we move to this next position. How many moves we need to move everything from the left to this box? Well, it's gonna be 1. In order to count it, we need to take this value, previous number of moves, because it could be a lot more moves to get here, and we want to add count to this. That's how we get this 1. So we put our 1 here, but we have one more 1, so we increment our count, and it now equals 2. And we go to this position. Again, we look back how many moves we already did to get here. Well, 1 move. So we're gonna carry it here, but also we're gonna add our count, and we're gonna get 3. And of course we want to check if we have a 1 here. If we do, we add it here, but our array ends here, so it's unnecessary. The same for the right, but we go in the opposite direction. Oh, wait a second, I have a message. Okay. It's exactly the same thing, but we move the other way. Let's rewrite it. So we start here. How many moves we need to move everything from here to our first position? Well, we do not have anything, so it's gonna be a 0. And we're gonna check if we have a 1 here. We don't, so our count variable remains the same. It is equal to 0. Now we go to this position. We take the previous value, it's 0. We add count to it, it's 0. So we get 0. But we have a 1 here, so we increment our count variable. And we go to this final position. We look back, we have a 0 here, and we add our count, which is 1. So we put, where is eraser? Is it? Good. Put 1 here, and we have 1 here, so we update our count, but we do not have to use it anymore because it's the end. So this is our right, this is our left, and to get the final result we need to combine it. So our answer gonna be 0 plus 1, 1, 1 plus 0, 1, 3 plus 0, 3, 1, 1, 3 is the final answer. Right? Right. So let's try to implement everything we just discussed. Of course, there is a much better way of doing that, but for now, let's go with it. And this guy, he used the fact that we always have a 0 in our first position. So he started from the second index, well, from the index 1, from the second element. And because we do that, it starts here, we already need to have our count variable. And it's gonna be equal, boxes 0. Right, you see, and we want to convert it to I because right now it's a string and we want to have an integer, right? This part minus 0, I don't know. Why do we need it? I think we do not need it. Maybe it's some, I don't know, he does it for style. Some funny gimmick, I don't know. But let's continue. So, for loop, calls it I. Let's close it because we do not want to just copy everything, you know, we want to understand the logic. So for I in what? From 1 to length something like this, right? And we want to update left I with, do you remember what we did here? We take the previous value, so we take left I minus 1 and we add, see, we add count, and then to our count we add 1 or 0 or whatever we have in this position. Sorry, I got distracted. So that's what we do, right? Right. Here. And the same thing for, well, not the same, for the right array, but we want to start from the end. But not from the last element, because it is always 0 from the next one, so at length -2 probably, we will see. And here we want to go from can we go backwards here? I'm not sure. Well, let's see what this guy did. And then we're gonna do everything a lot easier. Oh, well, that's funny one. It's a countdown. That's very nice. So he takes this oh, right. It's stupid. Plus we just need what we have in the last box. Here we need length -2. You see, every day we learn something new here. It's down to method. It's very useful sometimes. I always forgot about it. So here we're gonna use right, of course. Right, I +1, and this is the same. Now for 0 to length, you can just do length times do. Just to change something. Well, we need to combine everything, of course. Left eye plus right eye. Yes, it's good. But why do we want to have this array at all? You know, where do we use it? We use it here, but we can just do all the changes. Oh, how nice of you. Thank you very much. Raid me more. Hello. And we are doing things the ugly way here. So welcome everybody to this citadel of ugliness. But now it's gonna get better. So as I was telling you, we do not need all these arrays. We can do everything in just one go, like this probably, but we're gonna need some additional variables because we do not do this anymore. We do not have this left array. We want to store this value somewhere. Let's call it previous left, and the same thing we're gonna need for the right direction. And also we want to have two counters, not just one. count left and count right, and because they're all equal to 0, let's just make a nice one-liner. Now, what do we want to do? Well, pretty much the same thing. We have answer, what do we want to add? We want to add previous left, and we want to add count left, I think like this. Now we want to update our previous left, like this. So, and we want to update our count left finally. And it's gonna be whatever we have in our boxes array. To integer. No condom, Chris. I'm happy to see you. Now let's do the same thing for our right counter, you know. So it's gonna be minus I minus 1 and it's gonna be almost exactly the same thing, but we're gonna use the right variables. Everything is the same, logic is the same. And finally, not I, but this monstrosity, of course. Something like this. And notice in the description they ask to call the array answer. Let's satisfy this condition. Answer. If only number 1. In terms of consistency, maybe. Although there are many consistent streamers in our community. No, being number 1 doesn't feel any different than when no one is here, because no one is typing anything. It's just no condom Chris as usual. So it's almost the same feeling, but I appreciate having no condom Chris here always. So I think this is the best approach to these problems. We have these two counters. Of course, we still do like 2 goes. So we might as well separate them to keep it more readable, and then we won't need that many variables, but it's shorter, you know. And the best thing is that we always use our previous computations when in my original solution. Let's not talk about it like ever. Now let's go back to another problem I wanted to discuss. You know, recently I discovered this section of theory, and they give us some problems to solve. We already discussed, I think, all of those. So let's discuss duplicate zeros. Unfortunately, it's not. It's a bad interface. To solve anything here is it's bad. So let's go to our traditional interface. It's much more comfortable. Here is it. Duplicate zeros. So what is our goal here? Well, we have this array and we have all these zeros, and we want to double the number of zeros. After every zero we want to insert another zero, but we want to 57 viewers. Where are all they? Virtual viewers. Probably they just fell asleep immediately after they opened the stream. Yeah, exactly. 57 viewers, and it's just no condom Chris and Smart Coder 5 as always. But where is Brainless Society, you know? I think he was so tired yesterday that he'll never come back. So, yeah, we need to return an array of the same length. So everything that goes beyond this length we're gonna throw away. And there are many ways to solve this problem, of course. But notice that they want us to do this. Where is it? In place, when we iterate, you see. Of course, it would be very easy otherwise. We can just create another array, temp array, and we can iterate through our array. And we're just gonna add everything to the temp, and if it's a zero, we're gonna add it again. Something like this, right? And then we're gonna iterate again. Oh, let's do even better. Like this. Array I equals temp I, and it's done. And we do not have to return anything, I think, because it checks our original array. But we want to do everything in place. Again, there are different ways, and the simplest one, let's do this with index, each with index. well, each with index. Let's say if num equals 0, we're gonna just insert what was it? We're gonna give it an index first, right? So index is the same. We're gonna insert 0 or num or 0. Let's just insert 0. Yeah. And also we want to pop array pop to remove the last element of this array to destroy it, because we want to keep our length the same. And now we have a problem actually, because, well, imagine we go through our array, there are some numbers, and we hit 0, and we immediately insert another 0, and then we move to this index and we look at this and it's a 0, and we add another 0, and then we move. So it's a endless adventure of inserting and popping. So what we can do is to add some additional boolean. Last was 0. Let's say it's false by default. And when we do such a thing, we're gonna add another condition. If this is true, no. If this is false, we go this way. And do not judge, because it's a temporary solution. We're gonna upgrade a lot. Of course, we want to set it to true, and otherwise we want to set it to false, something like this. Maybe that's it, I don't know. Oh, so many zeros. How? It's not insert, right? It's I don't remember. No, it's insert. So we add 0. We pop. We set it to true. Oh, we need it outside, right? Excuse me. I only have 57 viewers. I can afford this kind of mistakes. The problem is insert is a very bad thing to do, because after every insert we need to shift all the other elements, and it's very bad in the terms of time complexity. It's a very bad thing to do. So what else can we do? We can do a funny thing using 2 pointers, believe it or not. So let's count all the zeros in our array. Count zeros. And now we're gonna introduce 2 indexes. One is going to be, let's also introduce this variable. So I gonna be length minus 1, and j is gonna be, what's it's gonna be, length probably plus all our zeros and minus 1. I think something like that. And now we're gonna launch a while loop. Probably something like this. That's right. So what do we want to do? Well, let's draw. So we have an array. What was it? I don't want to draw it, but I will. 0, 2, 3. And 0 for 5. And 1 more 0. So our I index is here right now at this position. And our j, where is it? It's length plus 3 zeros. So it's 1, 2, and 3. It's here, but we do not have an element here. And it seems like a problem, but it's not. So of course we want to do, because we want to modify our array on a go, we want to do this thing, but not immediately, because you can see that our j is far outside. We only want to do this if j is less than what? In our length, I would say. Nice. But how is this going to happen if we are here? Well, we're gonna move. So we're gonna decrease both of them by 1 on every loop. So we move and move and move and move. But we have zeros. For example, here. We check this condition. It's not true. But if it were true, if array I is actually a 0, what do we want to do in this situation? First of all, we're gonna move our j even more. Because imagine if we had some other numbers. If we had like 1 here, 2 here, and I don't know, 3 here. Now j is less than length. So we do this line. We take this 0, we put it here. But we want to have 2 zeros. That's why we move j to the left here. And we do this again. And actually we can just do 0, I guess. And because we only double zeros, duplicate zeros. So this is a 0, 2, and then we move both indexes by 1. Here, here. And actually I think that's it. That's why we're gonna iterate through everything using 2 pointers. We do not have to shift everything a million times. It's beautiful. Our length stays the same. We do not pop anything. It's a genius solution. The only question is how someone was able to invent such a beautiful approach. Because as you probably guessed already, it wasn't mine. And it's green. It's beautiful. Now let's go back to problem that bugs me for a long time. Well, 2 days, not long time. Where is it? Where I am? What's going on? Why everything is so slow? Maybe we have drops? No, no drops. And this is it's not here because we never beat it. It's unbeatable. It's unbeaten. Let me go to my notes. Yeah. This is a problem. Minimum area rectangle. Yes. Yesterday we hit time limit. Let's use this test case. Oh, of course, we need to submit to hit the time limit. I thought a miracle happened over a night, you know? Maybe some little gnomes solved everything. Let's use this test case. It's huge. So what can we do? Yeah. You know what is the problem here? Well, let me look at my own code. We count this difference in y coordinate here in the end, but it would be much better to do this immediately, and if this diff y is bigger than our where is it? And our min rect. No, if it's smaller, then we go here. Maybe that will help us. Let's see. Still too many. Maybe we do too many sortings, you know. We sort here and sort here, but here we want to sort probably or not. What else can we do? I mean, look at this monstrosity. And the same X everywhere. Obviously we can't build a rectangle using these dots. They are all on one vertical line. Okay, that gives us a clue. We only want here, we want to do this only. Wait a minute, we don't even want to add it to pairs if let me do something here. Hash key and value. So we're gonna take, nah, it's ugly. At some point I want to check if in some key I have only one point. If there is only one point, we do not need this line at all. It's useless for us. It's like this line too. It's useless. But when and hash key length more than one, and not sorted keys. Oh, not hash but sorted keys. No, that's right, hash key and hash I plus offset. It's almost painful. It also should be more than one, and this is a good pair. And that way we're not gonna have any pairs here, I guess. Case 3 is green. All the other cases. But why? Because of this? Oh yeah, of course. And doesn't equal 0. Mhm. It's one condition. Or, of course, if it equals 0. Come on. Let me look at pairs that we have. Huh. Let's get rid of this condition. Let's return everything as it was. I don't remember how it was, unfortunately. Let's see what's going to happen. So let's we have a problem here. I broke everything somehow. Now I broke everything. Oh, yeah, of course. I still have pairs here. what do we have in pairs? We have y coordinates, so it should be 1 and 3, and that's what we had here, right? So one and 3. God, let's look at pairs again. They're so close, I feel like they're very close. I'm so tired. 1 and 2. It can't be right. Should be 1 and 3. Okay, let's remove this condition for now. Not remove, but let's comment it out. And let's look at pairs. Of course, but oh, they won't let me because of this test case. Right. Okay, let's remove it for now. See, we have 1 and 3 here. So we have a problem with this condition. You know what? We want to have a separate loops, not loops, separate blocks for these two. No, oh, I see. Huh. But still it doesn't answer my question really. really, what if we do a separate block and we do offset here, so we collected all the pairs. Oh yes, that's a problem. Wait, not like this of course, but like this. What's gonna happen now? One, two. That's the wrong pair. Something happened and I missed it. Oh Jesus, I'm sorry. Oh no, I see. Thank you very much for following me, even when I'm sitting here in complete silence. But that's only because I'm so close. So close. So we went this pass. And offset is less. This thing shouldn't be here. Pairs should be empty. Why? Sorted keys. I plus offset. Offset is 1. We take it. Yes, if it exists. And hash key length. is our pair. What is this? No, it's alright. Oh. No, no O. I want to do a test. Let's say first pair. It's nothing. And here, if then we're gonna do this, but also if no first pair, like this. I just want to understand why. Yes, 1, 2 is wrong. Let's look at our hash, first pair, 1, and also at hash, at hash first pair 0. Oh, not like this, of course. No. So first pair yes, it's 0, 0. Like this, 0, 1, 0, 0. Probably debugging like hell. Oh, so first pair 0, 0. 1. Zero. I don't understand it. So in first pair, what do we have? We have keys. and keys are y coordinates. We have 1 and 2. So first pair 0 is a key 1. Let's take this key, the value from hash. That should work. Why doesn't it work? Okay, it's 1, 3. One and 3. And what is this? It's just 2. You see, just 2. And how can it be if we have this condition? Length should be more than 1. How is it even possible? Wait a second. So we have sorted keys I plus offset, and that is going to be our key here. Now it's gonna work. Well, not immediately, of course. We need to remove this. We do not need this crazy first pair logic anymore. But we debugged this sucker successfully. Let's check. Green. Let's go. Well, we've made some progress because it's a different test case now. Well, much better, right? Let's check. Let's return points count. I want to know how many elements we have in this. Okay. Well, it's better, right? So look at this crazy minimum area. Do we need to sort it? We better. I do not have time, so we're gonna continue tomorrow with this problem, but I want to solve something today. So what's it gonna be? Let's take something simple and fail miserably. No, let's solve something easy. What do we have on this page? Minimum subsequence of in non-increasing order. Come on. It's gonna be so bad. Oh. Let's sort the hell out of it. Nums sort. Right? I want to sort. So no, let's do this in different order. And our result is going to equal sorted nums last and right sum is gonna be equal the same thing actually. And left sum is gonna be equal sorted nums sum minus right sum and while right sum is smaller than left sum, also we want to have index and it's gonna be -2 right sum plus equals sorted nums index left sum minus equals the same thing obviously. Result we're gonna add Well, the same thing again. And we're gonna decrease our index. Something like this. Result, sort. Gonna hit time limit with such stupid approaches. Let me check. Okay. Wait. So that's it. Seven, 6. Oh. We have just 7 and 7. Oh, I see. We need this condition also. Because it is said here, not strictly greater. We need to make it stricter. Boa constrictor. Okay, it's done somehow. I'm happy with it. I have so many better things to do today, so I have to run for my life. Of course, there must be a better way. We're gonna have a 2 arrays and we're gonna add it. I'll think about it tomorrow. Yeah. Thank you for being here, my imaginary 57 viewers. Loved it. Loved it. Now I have to go. See you tomorrow. Approximately the same time. Bye bye.